Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 18. There's only one line passing through a given point with a given slope. Okay, so I'll explain that as we go throughout the lesson. And at first it's saying classwork opening exercise. It says to examine each of the graphs and their equations, identify the coordinates of the points where the line intersects the y-axis. Describe the relationship between the point and the equation y equals mx plus b. Now keep in mind, we already know that the m is the slope from lesson 17. The m is the slope. So we already know the slope of a is a half and the slope of b is -3. Okay, but this is not asking about slope here. This is asking about the y-intercept. So here's my y-axis in the first one, a, and here's the x-axis. They want us to know where the line crosses the y-axis, and that is right here. And that is the point 0, 3. So I'm going to move on to the next one before I point something out to you. In this one here, obviously the x-axis is down here, the y-axis is here, and the y-intercept, this line is right here, and it crosses the y-axis right here at 5, 6, 7. That is the point over 0 up 7. That's the point 0, 7. Okay, so now I want you to focus on this 3 and look over here, and you see this 3 right here? Well, that is the y value in our point where the line crosses the y-axis. And then again over here, this constant here is 7. And if you look down here, the y value is that 7, and that is where it crosses the y-axis. So in general, the y-intercept is the point 0, b, where b is right there. Okay, so now we know that m is the slope, b is the y-intercept, x is values we plug in, and y is a value we get from plugging values of x in. Okay, so here's 2 more. You try C and D on your own. Pause the video, see if you can figure out. And how about answering both questions now? What is the slope and what is the y-intercept? Okay, so now we're going to take a look at this. So I'm going to look at this point right here is the y-intercept, and that is the point 0, -2. And obviously, -2 is right there. So there's my y-intercept, 0, -2. And over here, I'm right here where I cross the y-axis, and that's -1, 2, 3, 4. That's 0, -4. And obviously, we see a -4 here. So there's our slope. Now keep in mind that not slope, I'm sorry, that's the y-intercept, -4. Keep in mind that the slope is simply the coefficient in front of the variable. So the slope is -2/3, which means go down 2 over 3, and look where we end up on the line again. And this slope is 5, up 1, 2, 3, 4, 5 over 1. So that's the slope. So m equals 5. B equals the point 0, -4. Or simply -4, I suppose. I wouldn't want to say B equals, because B is just -4. Which means that the y-intercept is the point 0, -4. Over here, the slope is -2/3, and the b is -2. The y-intercept is -2. Now keep in mind, now I want to discuss positive and negatives. This is the first time I've seen a negative slope in the last couple of lessons, a letter C. So if we are decreasing as we go from left to right, remember when we read a book, we read it from left to right. So as we're going to the right, this thing is decreasing. It's going down, so that's a negative slope. As I go from left to right, this is going up. As I go to the right, it is going up. So that's a positive slope. So negative slopes decrease from left to right, and positive slope lines increase from left to right. Okay, example 1. It says graph the equation y equals 2/3 x plus 1. Name the slope and the y-intercept point. Okay, so I could make a table and plug in a whole bunch of values now, but it's no longer necessary. This is my b, which is right here. Okay, so my y-intercept, notice it says name the slope and y-intercept point. My y-intercept point is the point 0, 1. And my slope m equals the variable coefficient, 2/3 x. My slope is 2/3. That would mean to start at this point, go up 2 and to the right 3. So there are my 2 points. We only need 2 points to plot a line. So I'm going to grab my calculator, or my ruler I mean, and draw a nice, neat line that's accurate. Okay, attend to precision, SMP 6. Rotate this so that we are going through that point, and then it continues on forever, both directions. So there is the line graphed through the y-intercept, and then the slope is 2/3. Okay, I want to discuss slope a little more. Keep in mind that the slope in this case would equal, and remember it's rise over run, so it's this distance here, which is the length of, if I called this P and this point Q and third point R, and then this is the distance QR, then my slope is the length of PQ. And remember, length can't be negative, so we put it in absolute values, divided by the length of QR. Okay, so that's the equation. The slope is the rise divided by the run, or the length of each distance. So from 1 to 3 is a length of 2, and from 0 to 3 is a length of 3. And as you can see, it's right there and right there. Okay, number 2, example 2. Graph the equation y equals -3/4 x minus 2. Always start with the y-intercept. So my y-intercept point, remember when it says y-intercept point, it wants the point, and it's the point 0, comma, b, which is -2, which means right here we're going to go down to -2, and we're at -2 on the y-axis. Our slope is -3/4, which means we want to decrease 3, go down 3, and then right 4. And my point is going to end up right here. And I bring my ruler over, rotate it around, trying to get this as accurate as possible. That looks pretty good right there. Okay, so I draw the line through those 2 points. I put arrows at each end, and that is a line with a slope of, now notice what's going on here. That's a distance of 3, and this is a distance of 4. So if I named this point P, and this point here Q, and this point here R, then my slope equals the length of PQ divided by the length of QR. And PQ is 3, and QR is 4. And since it's decreasing from left to right, we had to go down 3, right 4, then the -3. We're going in a negative direction, a distance of +3, if you will. Okay, so since it's going, so I would have a negative sign outside here, because if I put it inside, the absolute value of a negative is positive. So we're going in a negative direction, the distance of PQ. That's how I would represent that. Okay, so my m is -3/4, which is my coefficient. Okay, example 3, it says to graph the equation y equals 4x minus 7. So remember, we start with our b, and that's our y-intercept. So the y-intercept point is the point 0, comma b, which is 0, -7. So there's our y-intercept. Our slope is 4, so my slope equals 4. Now this is an integer. It's not a rational number. Well, it is a rational number, but it's not shown as a fraction. It's an integer, but I'll show you what we need to do in that situation. So if we still start with our y-intercept. So we're going to start at -7. That's where we're crossing the y-axis, so it's way down here at -7. So that's the point 0, comma -7. And we're going to make this a fraction. Let me change back to blue. We're going to make this a fraction. Well, any number divided by 1 is still that number. So 4 over 1 is the same as 4, and that is our rise over our run. So if I rise 1, 2, 3, 4, and run 1, then this is the point I'm going to end up at. Okay, so that is my slope right there. I need 2 points to graph a line. So I bring this down and line this up nice and neat. And draw a straight line. And actually I can go in both directions. Okay, so there's my line. So as you can see, it was an increase of 4 and a distance to the right of 1. Okay, so this would be my P. This point here would be my Q, and this would be my R. So my slope, I'll just do this one more time, is the distance of PQ divided by the distance of QR, which equals 4 over 1, which equals 4. And that is the number right there. Okay. Okay, exercise 1 says to graph the equation y equals 5/2 x minus 4. Name the slope in the y-intercept point. Okay. So I just moved this over from the previous page, so I didn't have to go back and forth and back. So I'm going to start with name the slope. Okay, the slope m equals 5 over 2, and the y-intercept point is the point 0, comma -4. So whenever it says point, you want it as an ordered pair, 0, comma b. So this is my m, and this is my b. Okay, so that's A. B says to graph the known point, the point 0, -4. Okay, there, it's graphed. Then use the slope to find the second point before drawing the line. So the slope is 5 over 2, which means to rise 5, go up a distance of 5, and then right a distance of 2. There's my point. Get my ruler, and I am going to put it right here and rotate it up. Try to be as accurate as possible and draw my line. Okay, close enough. Off by a smidgen here, but that's okay. So as you can see, up 1, 2, 3, 4, 5, right 1, 2. That is my 5, up 5 over 2 to find the next point that is on the line from the starting point, which is the y-intercept. Okay. Hopefully you're getting the hang of this. It's quite simple after we do a few. So pause the video, try to do number 2, and here we go. This is my m, this is my b. The slope is -3, and I'll make it a fraction so I know how to do my rise over run. And my y-intercept is the point 0, comma 6. That's my starting point. So I put a dot at 6 on the y-axis, and then I go down 3, right 1. 1, 2, 3, right 1. And I could do that again, 1, 2, 3, right 1. And you can actually do it forever if you have the graph big enough, set up properly so you can see more points. You can just keep going and going and going. And now let me get my ruler. Try to put that on 0 as close as possible. Rotate it around and draw a nice straight line. Not like that. Let's try from this end, and there it is. Okay. So there is the line with a slope of -3. That went down 3. So actually it's a distance of 3. So I'll just leave that as 3 because distance can't be negative. And a run of 1. So down 3, right 1. Since we're going down from left to right, descending, it is a -3. Okay, try 3, pause the video, come back, and then we'll see how you did. And here we go. So it says the equation of y equals 1x plus 0 can be simplified to y equals x. 1 times x is just x, plus 0 is still just x. So it says to graph the equation y equals x. Well, if y equals x and there's a 1 here from way over here, then the slope is 1. Or we could say 1 over 1. And my y-intercept in this case is the point 0 comma b, or 0, 0. So when we have an equation and there is no b, then we're going through the origin. Since b is 0, my point will be right at the origin. And then my slope, if there's nothing there, anything times 1 is, or x times 1 is still x, or anything times 1 is that anything, then I know my slope is 1. So I'm going to go up 1 over 1, like so. So there's 2 points. Grab my ruler. Okay. And draw a straight line through those 2 points. And there it is. And just so till we get the hang of this, that's a distance of 1 up. And this is a distance of 1 to the right. And 1 over 1 is 1. And 1 times x is simply x. So the equation y equals x is a really important graph. And it has to do with identities. Since this is the identity equation, it has the multiplicative identity in it and the additive identity. And we'll get into that in the future. Okay, so this is the linear equation y equals x. Number 4 says graph the point 0, 2. Okay, there's number 4. A, find another point on the graph using the slope m equals 2/7. That means I'm going to go up 2, and then I'm going to go to the right 7. 1, 2, 3, 4, 5, 6, 7. And I'm going to put a point here. Okay, grab my ruler, put it right on that first point, rotate it so it's going through the second point, and there is my line. Okay, so we start with our y-intercept. We draw the slope, so I'll write that in. This is a distance of 2, and this is a distance of 7. Rise 2, right 7. Connect the points, make a line. So there it is. Okay, does C ask us to draw a different line that goes through the point 0, 2 with a slope of 2/7? Okay, so now it says draw a different line that goes through the point 0, 2. So that's right, oops, go back down to this. That's right here again, the point 0, 2. And it says draw a line that goes through this point that also has a slope of 2/7. Well, if I go up 2 over 7, that's right here again. And so obviously if I do that and draw a line, you all should be able to see that it is the same line. They coincide. Okay, so what do I notice? The 2 lines coincide. Okay, number 5. A bank puts $10 into a savings account when you open the account. 8 weeks later, you have a total of $24. Assume you save the amount of money every week. Okay, A says if Y is the total amount of money in the savings account and X represents the number of weeks, write an equation in the form Y equals MX plus B that describes the situation. So if I write Y equals MX plus B, this is just simply substituting in givens. Y is the total amount of money in the savings account. You have a total of $24. Y is 24. Okay, so it says 8 weeks later, you have a total of 24, and the bank put 10 into savings account when you opened it. That is our starting point. We started with $10, so that's our B. Just like when we graph a line, the y-intercept, the B is our starting point in graphing. Our starting point in this equation of our savings account is the amount of money the bank put in at the beginning when they opened the account. That's our starting point. Assume you save the same amount every week and you did it for 8 weeks. That would be the M, that'd be the number of weeks, 8x. So your slope here is your rate of savings, if you will. Okay, so there's my equation, 24 equals 8x plus 10, or y equals 8x plus 10 if we didn't have that 24 there. So it says to identify the slope. Well, the slope is 8, or 8 over 1, $8 per week. What do those numbers represent? Okay, well, the 8 is $8, and the 1 is weeks. $8 per week. Remember division, you say 8 per divided by $8 per week. That's times, I should say. 8 weeks later, 8 times the number of weeks. 8 per week. Okay, so the numbers represent dollars and weeks. C says to graph the equation on the coordinate plane. Okay, so we're starting with our initial $10. So that is going to start right here. The bank gave us $10 when we opened the account. Assuming that we deposited the same amount every week for 8 weeks, then our slope is 8. So after week 1, we'll have an increase of $8. So if I had $10 in week 0, in week 1, I'd have an increase of $8. I would have $18. Is that correct? No, because if I continue this, and I'm going to keep doing this because I did it incorrectly, but as I do a problem, I think about the whole concept, and I make sure that it makes sense in the situation. So if I went up 8 again, I'd be way up here somewhere, and that's only after 2 weeks. But it says 8 weeks later, you have a total of $24. So I've already exceeded the 24. So if I drew a line, let me just do this as my explanation to my error, but errors are good because we learn from them. So if I drew a line right here, that's my $24 line. That is supposed to happen at the end of 8 weeks. So if I'm at week 0 when I open the account, 8 weeks later, I'm supposed to be right here, not way up here, okay? So obviously this is incorrect, so I will erase that, and I will erase that. So what did we do wrong in our equation? Okay, they did not give us the slope, they gave us the x. Okay, so I'm going to fix my mistake, and I'm going to put m here, and I know that x is 8. That's number of weeks. So in order to find my slope, I need to subtract my b, which is 10, and I'm going to get 24 minus 10, or 14, equals 8 times m, which is 8m. And to find out what m is, I divide both sides by 8. So my m is going to be the reduced 14/8, or 7 over 4. So $7 every 4 weeks. So if I rise 7 and run 4, which is what this says to do, I'm going to go up 1, 2, 3, 4, 5, 6, 7, run 1, 2, 3, 4. Now my point is here. Okay, so again, I'm already at my total here. It's too early, and now I'm looking. I am not paying attention to my unit of measurement here. My scale is in $2 increments, so I need to be careful with that. So let's do that again. So rise 7, 2, 4, 6, 7 is halfway, and then run 4. 1, 2, 3, 4. Okay, so now that point is right there, and that is 4. So it's going in measurements of 1 per week here, and up by $2. So I need to be careful of my scale factor, or not scale factor, but my scale of my y-axis here. So if I'm now at this point here and I go up 7 again, well, this is 1, 2, 3, 4, 5, 6, 7, and over 1, 2, 3, 4. I finally have my points located correctly, and I will draw a line that represents this scenario. Okay, notice I did not draw the line here because we can't go backwards in time. So this isn't really a line, this is a ray, but we could go the other direction, but in the context of the problem, it really doesn't make sense. So I'm just going to leave that as a ray rather than a line. So we're not going to go less than 0 weeks. Okay, so there's the graph of the line. So our slope was 8, and our y-intercept point was 0, 10. So 0, 10 represents the money the bank gave us when we opened the account. Okay, enough there. D, could any other line represent this situation? For example, could a line through the point 0, 10 with slope 7/5 represent the amount of money saved each week? Explain. So what they're saying is if I graphed a point 0, 10 with a slope of 7/5, I'll do that in black. So here's 0, 10. Slope of 7/5 means to go up 2, 4, 6, 7, and over 5. Now this point is right here. So if I bring my line or my ruler over here to draw my straight line through this point, okay, is that the same? Well, the answer is no. That has a less steep slope, 7/5. This has a slope of 7/4, and this one has a slope of 7/5. Okay, so this one is smaller. This is 1 2/5. This is 1 3/4. 2/5 is 0.4. 3/4 is 0.75. This has a steeper slope, and therefore a faster rate of saving money. So that's what's happening there. So I explained it without writing. Okay, it could not represent the amount of money in this situation. It is putting money into your account at a slower pace. You're putting $7 in every 5 weeks instead of $7 every 4 weeks. Number 6. A group of friends are on a road trip. After 120 miles, they stop to eat lunch. They continue their trip and drive at a constant rate of 50 miles per hour. Whenever you see constant rate, that is our slope, our M. We used to use R, we used to use K for constant of proportionality. Now we're using M. They all mean the same thing. A says let Y represent the total distance traveled. Okay. Let X represent the number of hours driven after lunch. Write an equation to represent the total number of miles driven that day. So Y equals MX plus B. My slope, my rate, constant rate is 50 miles per hour. So Y equals 50X. And we want to start, we already went 120 miles, and this is asking how far we've traveled the entire day. But this is our speed after lunch. So we're going to go a certain distance. Distance equals rate times time. So X will be our time. Y will be our total distance. But we already traveled a distance of 120 miles in the morning, so I'm going to put that as my starting point in the afternoon. 120 miles plus 50 miles per hour will equal our total. So there's my linear equation. Hopefully you understood that. So we started at 120 miles after we stopped for lunch. We're going 50 miles per hour. So I have to look at my scale here. So we're going, hours is in 1 increments, and miles per hour is going in 20 mile per hour increments. And our slope is 50, which means to go up 50. So my m is 50 over 1. So that's right here. The slope is 50, or 50 over 1, which is miles per hour. And the y-intercept point is the point 0, 120, which represents miles driven before lunch. Okay, so I'm at 0, 120, rise 50, 20 to 40 is 20, there's 40, there's 60, so I want to go halfway between. So I will draw lines in a different color. So I'm going to go up 50, that's a distance of 50 miles per 1 hour. So I should have a point here. If I continue that, there's 10, 20, 30, 40, 50 over 1. 20, 40, 50 over 1. 10, 20, 30, 40, 50 over 1. And so on, and so on, and so on. And now I'm going to draw a nice straight line using a ruler. Bring this down to your y-intercept. Of course, you're not using an electronic version, but if you were, that's what you'd have to do. And then rotate it so that we draw a straight line through all the points that are on there, like so. Okay, so there's our equation, the graph of our line, linear equation. So now I can answer a bunch of questions just looking at this. So I've already gone 120 miles in the morning. If I drive for 1 more hour after lunch, I will have gone 170 miles. If I drive for 2 hours, I will have gone 220 miles. If I drive for 3 hours, I'll have gone 270 miles, and so on and so on. Graph the equation on the coordinate plane, check. Could any other line represent this situation? For example, could a line through this point with a different slope represent the total distance the friends drive? And the answer is no. The 75 miles per hour is greater than 50 miles per hour. So any line that is different than this one would result in driving faster or slower depending on your slope of your line. The smaller the slope, the slower you go. The faster you go, the steeper the slope. And that is the end of lesson 18. Review the lesson summary and go to your problem set.